Hi, Alan Forsberg here with an introduction to Vietnam's monsoon system. As you learned from the distance learning modules, as we move into Northern Hemisphere summer, the Asian landmass becomes warmer than the ocean. As winter sets in, the continent becomes colder than the ocean. These temperature differences create pressure differences which result in large-scale wind reversals known as the monsoon. So on the left, low pressure overland sucks in moist air off the ocean, producing the summer wet season for most of southern Asia. On the right, dry cold air blows from the continent towards the warmer ocean during the winter dry season. However, Da Nang does not fit this pattern. The central coast of Vietnam is quite dry in June and wet in December. As we can see on this graph of rainfall, the rains in Da Nang start 3 months later than in the north and south of the country. Why is this the case? Why does Da Nang have such a delayed rainy season? And what is missing from this map that might help explain the late rainy season? Topography. As you can see from these animations from the distance learning module, monsoon winds interact with local topography to generate complex precipitation patterns. We learned that the hills in San Francisco play an important role in creating distinct microclimates in different neighborhoods. For example, when I lived in the Castro and the Mission districts, we almost always had sunnier, warmer weather than the neighborhoods on the other side of the mountain. So why is it warmer and drier downwind of a mountain? It has to do with the enormous amount of energy transferred from place to place in the hydrologic cycle. As the sun heats the ocean, water evaporates and absorbs latent heat. That water vapor is blown elsewhere by the wind, where it may condense into a cloud and precipitate, releasing that latent heat. A snowstorm releases a surprising amount of energy. Condensation releases latent heat. All of the energy that it took to get that water molecule airborne is released when it comes in for a landing on a cloud droplet. And that latent heat heats the cloud further, increasing convection. So what happens when moisture-laden winds encounter a mountain? As the air is forced up, the water vapor condenses and releases its latent heat. Descending, drier, warmer air creates an arid climate on the downwind side. Now these are winds blowing from the southwest. What happens if moisture-laden winds blow from the southwest? You get rain on the southwest side of the mountain and arid conditions northeast. But what happens if moisture-laden winds shift from southwest to northeast? The pattern of precipitation also changes. So let's look at this with real historical climate data from Null School. Here, southwestern monsoon winds in June are bringing rain to many places, but Da Nang remains dry. Six months later, most of southern Asia is dry, but Da Nang got record rains. What are the northeast monsoon winds blowing over, and where did all that water come from? Here we have a map showing departure from normal sea surface temperatures. The waters northeast of Da Nang are over 6 degrees Fahrenheit warmer than usual, reaching the lower 80s. Bathtub water. So as the monsoon winds pass over all of that warm water, Coming all the way from Okinawa across the southern coast of China, they become very warm and moist. When those moist winds encounter the mountains of the central coast, they dump lots and lots of rain. On December 9th of last year, Da Nang experienced its worst rainfall in history with over 25 inches of rain in 24 hours. It is important to note that the amount of water air can hold goes up exponentially with temperature, a fact that policymakers should be made aware of. Thank you very much.